Welcome everyone to this session on hitting the refresh button on your Spring Boot application. So before we start, who's using Spring Boot? That's pretty much all of you, except you use Spring Boot? Yes, lazy. Those of you who are using Spring Boot, are you already, raise your hand, sorry, if you're already on Spring Boot 3. Okay, there's a few more. All right. So this talk is really about upgrading your application, and that takes time sometimes, or you have other things to do and didn't take the time to look at the release notes or anything that can be useful to you. And we talk a bit about those little features in Spring Boot 3 that will help you out. So I'm not going to cover anything from Spring Boot 2. As you know, it's already end of life at this time. So if you haven't upgraded yet, you really should. 3.0 is also end of life, and 3.1 is about to be. So your first stop is really 3.2 now, unless you have an enterprise subscription. Oh, there you go. Thank you. Done. Sorry. So let's have a look to an app. And usually what I do is I give you a quick walkthrough of the app and what it does. It's running on 2.7, and then I upgrade to the later 3, 3.2.5, actually. But that's not very interesting, I believe, for an audience that's mostly on 3. So let me do that again. If you're still on Spring Boot 2, you're not missing anything, right? OK, let me check out that. All right. OK, make sure that maybe I refresh, because I'm going too fast. There we go. There we go. OK, perfect. Oh, not working. Perfect. OK, so user experience first. Let's pretend I'm starting on that project. I don't know what it is. I've just been asked to look at it and improve it. And I can see that, yeah, that definitely doesn't work. Let's have a quick look to why. OK, JDBC connection. Flyway doesn't work. Connection refused. OK, so I need a database or something. Let's have a look to the README. What's that? OK, so the README is telling me run Postgres. Perfect. And what? I need a default password and secret and whatnot. OK, so not great, right? You have to figure out what database you want to use and run it. So we'll come back to that later. Let's use that Postgres database for now. Starting the database. And then oh, it's also telling me about some mock server thing. OK. Let's do that. There's a script, apparently. OK. So scripts, run mock. OK, perfect. Looks like it. It did start. OK, good. So it's a online status page. Let's assume like it's gathering information from many different components, giving you status about it. And let's pretend for the purpose of this demo that it's a high traffic website. So there's a lot of people actually going to this status page because Spring Gaming is so important. And so you need to be able to handle a lot of traffic, and there's like some I/O operations that are happening behind the scenes. The actual detail does not matter. So I have my application running on the latest, which is great, except that I had to, figure out how to start a database and whatnot. It's running on 3.2.5. It's running on Java 17, which, if you are not aware already, is the base requirement for Spring Boot 3. But did you know that actually there is a new LTS in town already? So Java 21 is out. Actually, 22 is out already, but it's not LTS, so don't use that in production. So maybe we could also upgrade to 21 directly so that we can benefit from nice features. OK, so let's do that. Making sure I have 21 here, which I think I am. Yes. OK. Let's restart my app. Nothing should happen, hopefully. And it's still running. OK, perfect. So if I look at the threading model of my app, you can see here, it's the debugger from IntelliJ. There is a bunch of HTTP threads actually waiting for incoming requests. So that's the scenario of high traffic website I was talking about. You can see also that there are like some scheduling tasks. You see it running actually right now. Some scheduling tasks running to accumulate information from remote services. So this web app is doing quite a bit of things with I/O, and there would be one way to actually improve things now that we are running on 21, and that's virtual threads, also known as Project Loom, for those who know it about that with that name. So who knows about virtual threads? It's important because if you don't raise your hand, I know I have to explain it, otherwise I can skip it. So let's try again. Who doesn't know about who knows about virtual threads? Sorry, okay, so most of you. All right. So to recap, because I think it's quite important to make sure we're on the same page. Virtual threads is a way for an application to scale out without using platform threads. So the default model you've known so far is you have an application which uses thread. Those threads are mapped to an OS thread, which is also called a platform thread. And those threads are limited by the architecture of the machine. So you can't have like millions of threads, because each of those threads, they consume memory, and they need some context, because switching on the CPU, switching from one thread to the other is actually quite costly. Creating a new thread is also quite costly. I mean, it's not like a huge cost, but it's still a cost if you're trying to scale. At the same time, if you look at an application that uses a lot of I/O, you'll see that most of those threads are actually waiting for something to happen from the other side. So if you have an application that uses a lot of I/O, what I mean by that is if you have an application that queries a database, wait results from a database, or query a remote services like this one, actually querying those components to see if they're up or not. So if you have a lot of I/O, those threads will wait. So those limited resources will be at no use. Virtual threads, also called green threads, it's a way to provide you the same programmatic model without those constraints. So it's not a real thread, but it's put on a real thread when it's running. And when it's not running, it's sparked out. And something else can use the real thread to perform some processing. So this is a feature that's available in many languages. Java had a preview for that since 18, I believe, if I'm not mistaken. It's been GA since 21, so you don't need to enable any preview feature if you want to use it. So that's actually quite a coincidence, because we're running on 21, so we could give it a try. So let's have a look to our configuration and see what it takes to use virtual threads. So this is the config of my app. I can see the database and some flyway stuff. We'll talk about that later. This is the thread pooling, because this is huge traffic web application, apparently, blah, blah, blah. And so you can enable virtual threads. You can opt into it with a single property, and everything that Spring Boot auto configures for you, it will use basically that guidance from you to apply what can be applied to virtual threads. So you may wonder, why don't you enable virtual threads automatically when you detect the application is running on 21? That wouldn't be a wise choice, because you can't just enable virtual threads like that without thinking about the use cases of your applications. For instance, if your application is heavily CPU bound, virtual threads will not buy you much. And there are also some constraints of using virtual threads that we'll touch shortly. So you can see the difference here, where actually the actual threads, so the real threads, you see that the execution pool for Tomcat is gone now, because we don't need to keep a pool of 20 threads around. We just allocate a virtual threads, and it's mapped on a real thread when it needs processing. And same thing for the scheduling. So the scheduling task executor has been switched to virtual threads capable, and same thing for the application server, same thing for your database connection pool if it supports it, etc., etc. We also provide an API for cases where we don't create the thread pool for you. So if you create it yourself, then we provide you some conditions where you can automatically detect that your application is running on virtual threads, and then you can apply the necessary changes. All right, so one thing that you may wonder now is if you know about Spring and Spring 5, you know that in Spring 5 we've introduced the reactive stack as a way to scale out and as a way to address certain use cases where you may want to improve the usage of your CPU architecture. We have now virtual threads, which is offering a different option, but in the blocking model, as you know, the reactive world is non-blocking. So okay, those are still two options. The reactive stack is not going away. So two options, you can choose which one is better for you, and we will continue supporting them. On the client HTTP side, though, if you know about REST template, who knows about REST template? It's so hard to raise your hand, I know. I know all of you know about REST template. And you may have seen that in the documentation, as of 5, we've announced that REST template is in maintenance mode, which made a lot of people a bit angry. I wouldn't call it really angry, but puzzled, I would say. The reason why we did this is because REST template is a 20-year-old API now, so it's not easy for us to meet the demand of a modern API, because asking us to add new methods to it is not really helping. We've introduced the web client, which is using on the reactive stack in Spring Framework 5, as a really great way to handle those use cases. But with virtual threads coming up, we wanted also to offer some options for those who want to stay fully on a servlet-based stack with a blocking model. And so we've done something that I want to show you now, which is called RestClient. So before I do that, let me run those tests. So if you don't know about this one, it's actually quite convenient. It's part of the slice test in Spring Boot. It's a way for you to test a piece of your application. So by doing this, essentially, Spring Boot will auto-configure the test, if you will, for HTTP test-specific features. So I'm injecting the REST template builder and some mock server, and I can essentially test my client without any HTTP interaction, actually not a real HTTP server. Okay, so let's have a look to the actual implementation of that thing. And it uses the REST template. And let's see what it takes to use the new REST client, right? We want to give it a try with the new API. So the REST client is actually built with the purpose of making the migration smooth if you have heavily involved into REST template configuration. So you can create a REST client directly from a REST template. And everything like your mappings and your filters and your interceptors and whatnot, everything you've configured on the REST template will be honored by the REST client. We'll see other options down the road. Okay, so it's complaining about that because it's not a REST template anymore, but rather it's a new API. Let's say I want to say accept JSON. That's the thing at the top that is actually doing. And with REST template, it's a bit of a ceremony because you need to create HTTP headers, and it adds a bit more to your code. What we've tried to do with REST client is map to what the web client API does. So if you've used the web client, this should feel quite similar to what it does. Okay, let's have that. Yep. And then I can get rid of all of that, and it will do the same thing. So let's try to make sure it still does. It still does. Perfect. So that's the first step, and then the second step is once what you want to get away from REST template configuration altogether, you want to use the new API, including for config. Then, as always, Spring Boot as you covered, so you could inject a REST template builder, a web client builder, or a REST client builder now. And it will apply the things that Spring Boot has detected from your configuration. Okay, so now it's moaning that it can't work anymore. Yes, I know that. So let's fix it. And the other one is this one. Oh, it's called a builder. That's better. Builder, I said. Yep. Okay, perfect. All right, so that was one of the main topic. Once you switch to Spring Boot 3 and you have like the Java 21 upgrade that we recommend, because jumping from 17 to 21, you have like the benefits of everything that the Java platform team has done. And it's quite a bit, as we will see hopefully at the end of the session if I have time. You have new options, like you can enable virtual threads depending on the kind of applications you're running. Remember, if you have a highly IO intensive application, that might be a good fit. If it's like CPU intensive, it might not be. Okay. Be careful also about issues like thread spinning. That you will know for sure if you use virtual threads. Because thread pinning is when in your code you lock the platform thread. That's going to be problematic because the thread is supposed to be parked once it's not in use. And there's also the problematic of you moving a constraint to a different place. So if you have like a thread pool of 20 threads with platform threads actually constraining the processing. So you will process at most 20 tasks at the same time, if you will. If you switch to virtual threads, you can still limit it, of course, with the option. But the fact that you can do so many things now more without the constraint of the number of threads, you may move the constraint elsewhere. Like you may consume way more memory all of a sudden because you actually not constrained in terms of parallelism. So keep that in mind. Just not switch virtual threads thinking that it will fix all your issues, because it won't. Without actually carefully looking at your app. RestClient, new option, new API. As you can see, it's giving you a fresh new look to the blocking model with the HTTP, the regular HTTP client. All right, something else I want to show you is some of the improvements we've done in terms of developer experience. And that's not really for your users, but more for you and your team. As you can see, my tester, oh, okay, I forgot to do one thing first. Let me kill that thing. Okay, make sure it's done. Okay, so I only have the mock server running, which is good. That's what I want. So the Postgres database is gone now. And you can see my tests are still running fine, okay? Because I don't know, the team working on that, they wanted to not force you to install a database to run the test, because like it's too many options. But if you want to run the actual application, then you need to figure out how to get a database somehow. Whatever, their choice. If we look, and it's true that an embedded database is convenient. If we look at the migration for Flyway, we can see that we have two schema now. Because running H2 in Postgres compatibility mode, is not really the same thing as running against Postgres, because there are always subtle differences. And in terms of the schema, sometimes it won't accept everything that Postgres does. So you need to make some compromise. The idea is to remove all of that, right? To run your test against a real database, or the actual real database that the application is using, and removing the complexity in your setup. All right, so who knows about test containers? That's almost all of you. Interesting. Okay, so test containers, for those who don't know what it is, it's a library that allows you to run containers in tests, hence its name, and it interacts with Docker. It gives you an API where you can say, okay, I want to start a container with that image. It gives you an API, then you can actually look into the container, extract the information like the host, the port, and things like that. So in order to use it, you need to add some dependencies, which I'm going to do here. That's Testcontainers. There we go. So I'm adding the JUnit integration, which I'm going to use in a moment, and then Testcontainers as this system for each supported container. They have a module that gives the API. So in this case, I'm adding the PostgreSQL module because that's what I want to use. Let's go back to one of my tests that we haven't seen yet, actually, now that we switched directly to 3. Let's have a look to that. So you remember RestClient test, it actually looks only for HTTP client-related stuff in your config. Auto-configure only that, does not do any scanning of extra components, does not start the web server, nothing. A data JDBC test is doing the same thing. It's going to configure your data layer, start Hibernate, data source, flyaway, whatever. Scan for your repositories if you're using that. And in this case, it's integrating with data JDBC test. So let's see where we are. So still running against H2. What I want to do is I want to use Testcontainers. So, come on, Gradle, you can do this. Yes. Disable without Docker. True. Yeah. So I want to enable Testcontainers. So essentially, it's the integrations with JUnit I was talking about. And then I can create a container. So this is the Testcontainers API. As you can see, they offer a PostgreSQL container. I'm giving it the image name, and as you would expect, it will download that if necessary. Start the image with some random port because you don't want that to actually start on the port that Postgres is using. And you can then look at the Postgres actually container and ask for its port and then connect to it. And that's what this line does. It's actually connecting the container with Spring Boot. So as you all know, Spring Boot, you will recognize those properties, which allows you to configure Spring Boot and tell it where the database is. So if we go back to our properties, those are those ones. It's the same. But in the case of the test, what I'm doing is I'm saying, OK, a container has started on that port, localhost, obviously, or whatever IP the Docker daemon is using. And then I want that test to connect to that container. And finally, the last thing we want to do, and there's a short story about that. There we go, none. So you have to write this, unfortunately, because we don't detect yet that your test is using Testcontainers because it's a bit like unrelated. And so we need to ask Spring Boot to stop replacing the database with another database and let the real database run. So the funny story is I was a bit annoyed by that when I was preparing the demo, so I talked to the team, and they reminded me that I was the one creating an issue to fix that a year ago. So there's that. OK, so if we look at what happened now, you could see Testcontainers being involved. It's actually downloading the container. It's actually starting the container on a random port. And then the rest of it is like happening as you would expect. I'm going to quickly do that for the component repository tests, which is this one. There we go. And this containers, and make sure it runs. All right, it does. And so once I've done that, then I can start like pruning things a bit. So I don't need like an H2 schema anymore. I can only use one schema. Of course, there's only one file, but imagine there were like tens of them. Then I can simplify also my configuration because the vendor was the thing that was flipping between H2 and Postgres. I don't need that anymore. I also don't need the H2 dependency, so I can get rid of that and refresh. And so I'm basically where I was, except that now, if I don't have a database for testing purposes, one will be provided to me automatically as long as I have Docker on my machine. Okay, so that's quite an improvement compared to before. It's all good and nice, but if I start my app, yeah, still not working. Still very poor experience of having to figure out where to find a database. And you probably know what I'm going to say next. There is one thing where you can configure things for an application. It's Docker Compose, where you can configure services, right? So let's do that, if you want. So I have a single service now with essentially a copy-paste of what I had in my Docker run command, which is this, right? So it's pretty much the same. So what now? What do I do? So then you could update the README saying you need to run Docker Compose up -d so that it runs in the background, and then you can start the app once it has started, and blah blah blah, which is a bit painful. So what if we had something that would be a bit more helpful? So there's that, and there's also how can we bind the service that has been configured by Docker? Because right now there's a mapping. There's a mapping between the two, right? So I'm actually starting on localhost on that port, so things will work because that's what the application configuration expects. But you may have different options, like you may want to configure to a random port, or for the same reason for the test as for the tests. So that's a new feature that we've added in Spring Boot 3, which is Docker Compose support, which is, as you can see, a development-only feature, so it's not like something you need to use elsewhere. And as you would expect, what it does, it integrates with Docker Compose. So it looks in your directory, it sees if it finds a Docker Compose file. If it does, it looks if the services need to be started. If they need to be started, it starts them, and then it links the application to the containers, and then the application starts. And so I have my application now running, and the underlying database has been started for me automatically. It works also if you run from the command line. So if you use mvn spring boot -run, or if you use gradle-w boot run, that will automatically take that into account. So it will also start the database if it needs to be. But there is one thing that we don't really see. See how does the link between the two is done, right? Because we haven't seen that. How did the Spring Boot application connect it automatically to those Docker containers started for us? Because if we go back to our tests, we can see that there is a bit of a ceremony here where you need to fill in the registry and you need to know about those properties, you need to know about the container. It's a bit boring, right? So yeah, we've done also something for that. Let's have a look. Copy paste that, and it won't be a surprise, I guess, if I type this. So support for Testcontainers, and let's have a look to what you can do with it. All right, so let's see what's happening if I do that. Okay, it works. Service connection. So that's a new API that we have. It allows you to, it provides an API where you can, based on where it's being located, so in this case it's being specified on the PostgreSQL container, you can get a callback and say, oh, I can handle that. I know how to deal with this. And so you have one place, one implementation that takes the container, gets the username, the password, and the URI, and set it to the registry automatically. And that's how the Docker infrastructure is working. It's the same thing. So we do have support for databases, all kinds of store. So for instance, if you use Elasticsearch or Redis or whatever, we will automatically bind to that. And if there is a services that we don't support, like something you use in your company, then you can implement the API, stick service connection on it. We will call you, and then if you can handle that, you say, I can handle that, and you're responsible to fill the registry with whatever needs to be done based on the container or the Docker service in the case of Docker Compose. All right? Any questions so far? That's good. So the other one, by the way, I said I wouldn't talk about Spring Boot 2 too much, but you can do that with Spring Boot 2. I'm not supposed to tell that because I'm supposed to tell you you need to upgrade to Spring Boot 3. But that actually will work with Spring Boot 2. But it's boring, so you need to upgrade to Spring Boot 3. OK, so next up is SSL. So we've been working quite a lot with like some feedback from the community that our SSL config is like scattered all over the place. So if you have like one certificate and you need to use that certificate against multiple services, then it's a nightmare because you have to reply the configuration every time. So we did something about that with SSL bundle. So I want to show you that quickly. That should be this. So Spring Boot 3 has this notion of named bundle. So the name of the bundle in this case is this. And you configure the SSL bundle with the certificates and the private key and whatever needs to be configured. And then that name can be reused everywhere where we configure SSL. So everywhere we have support for auto-configuration support for SSL, rather than providing the configuration again, you just provide a name and we will make the link between the two. Another feature that we've introduced recently is the reload on update. So if you do certificates rotation and the certificate is on the file system, then we will automatically detect that and reload the certificates for you without like interrupting connections and everything. So let's have a look to that in action. Let me go SSL and server SSL bundle example.org. That should do it. So I'm not going to go on my browser again because, oh, that's not the app. Sorry. I'm not going to start to look at the browser again because I'm going to have like warnings from my IDE that I should not go there. So rather, I have here. I have something that gives me the current certificates for the application. If you're wondering what the script does, it's nothing like very complex. Right, so this is the certificate the application is running. I also have a script to update the certificates. Okay, so it's been updated. We can see here that it's been updated because it's blue. If you don't see blue in the back, I won't blame you, but it's blue. And I can see here now in my logs that something happened. If I can increase that there, yes. So we've detected that the certificate has changed and we've automatically refreshed it. So you can see it ends with TFHMZ. Let's get it again. And definitely doesn't end by that. So feature in terms of config, you centralize your SSL config. You also have the reload on update if you choose to use that. Next up, and I'm going to do a checkout because there's quite a bit of code, force checkout even. So I wanted to talk a bit about observability. Who of you were using distributed tracing with Spring Boot 2? Spring Cloud Sleuth? Ah, okay. So who knows about distributed tracing? Bit? Okay. So distributed tracing is quite important for in cases where you have like multiple services that are like involved in a single request and you want to trace what's going on in those services, right? So you have one service calling a second service. That second service is panning two requests to fetch some data, whatever. And let's say you have like a performance problem or you have something that goes wrong. You would like to see that what happened, all the individual services participating in that request. Hence the term distributed tracing. The way it works, in a nutshell, I'm not an expert, but essentially you have this notion of trace that has an identifier, and the identifier is conveyed from one service to the other, and that's how things get reconciliated. So I'm going to show you that in a minute. You'll see it by yourself. In Spring Boot 2, you had like metrics provided by Micrometer and the actuator with extension to many monitoring platform, whatever you want to choose. And Spring Cloud Sleuth as a separate project for distributed tracing. What we've decided to do with Spring Boot 3 is to harmonize everything. So rework the observability story and make that really something more coherent and part of Spring Boot itself. So for that, we had improvements in Micrometer. Micrometer introduced a new API that we can use to provide those features, and the core framework itself started to provide those observations, as well as other modules in the portfolio, rather than having Spring Cloud Sleuth actually having to integrate with everything, basically. So the thing I have changed, the commit I have checked out here, it's not doing actually quite too much. It's mostly about a services definition and some dependencies. Anyway, I will share the GitHub repo with you with one commit per demo like I did, so you can follow along later on if necessary. So I have a new services on top of the Postgres database is Prometheus. Prometheus is a way to scrap metrics. I have Grafana as a way to display those metrics. And finally, I have Zipkin, which is the services that I'm going to use to store distributed traces. So the nice thing is because everything is now configured the way I've explained, I don't need to do anything, right? I just run in my ID and those services will start for me. So I don't need to search for them. I don't need to know if I have to, run Docker Compose or whatever. We can see the container are starting here. And once they're healthy, then the application is starting and connecting to it automatically. Give me back my, go away. No, I don't want that. Hello. Ah, there you go. Okay. So let me show you maybe one thing very quickly before we get there. That's not the client. That's probably this. Yes. So we have this very complex, as you can see, checker from our status page. It's running every 5 seconds. What it does, it takes all the components. For each component, it's issuing a request. That's the client that we moved to RestClient, if you remember. So it's issuing a query to get the status, and then it's updating the status in the database, and that's how the status shows up. Very complex, as you can see. But it's all like a regular Spring API. There's nothing really funky about that. So let's have a look at the outcome of this. Where we go? Oh, I don't have any traces. Why? That doesn't sound good. Must have a trace here. Ah. Last 5 minutes. Very weird. He knows about that. So. Okay, so I don't know why the trade doesn't work. That's really strange. Let me check quickly. Is it 3,000? I think so, yeah. So that's my Grafana working locally. Import dashboard. Yep. Aha. Okay, Prometheus, that's me. Must be something new because it. Okay. I won't say that I know what's going on, but I have an idea, which has nothing to do with this, but rather a security update on my laptop today. I'll give it a try and let you know. But essentially, I'm afraid I can't show you that right now. But with the traces, what you would have seen is a trace for every scheduled task showing up, with like the total time of it took to actually trigger, contact all the components, and you could see one trace behind that for every RestClient calls, because RestClient is actually instrumenting this. And so you could have seen that the trace for the component that's not available is much longer than the other ones. So you could have seen like some kind of performance issue or whatever. But obviously with the diagram, that probably reads better. If you're interested by that, you could rerun at home with the latest commit. Just go to localhost 9411. Nothing to do, just click run query, and then you'll see the query here on the left and drop down. Okie dokie. I have one more demo, which involves me switching to Spring Boot 3.3, and we'll get back to Java 17 versus Java 17, 21 versus 17, sorry. Where is it? Database. Okay. Using 21. Let's see if it's happy. Seems happy. Yes. Okay. Okay. So I want to show you some work we've done in improving startup time and improving like deployment scenario, optimizing deployment scenarios. As you know, you can start your application very easily by pointing to its jar file. Making sure, yep, I'm on 3.3. So with that, I have my application running in around 2 seconds. Why is it complaining now? Aha. Yes. Forget that, we fix it. Actually, I detected that on stage 2 weeks ago. Wait, that was fixed. It should be fixed. Yes, it should be fixed. So ignore the exception. So I have my application starting in 2 seconds. Who's actually running their application in production this way, like running the repackage or this way? Nobody? 1%? Okay. So if you use build packs, if you create a container for your image and you use build packs, you'll see that it will extract the repackage archive, create some optimized layers for the various entries to reuse layers rather than you have to recreate everything when you change one class. And it will optimize the application. Optimize the application the best it can. So unpacking actually has a slight boost, because if you extract the repackage archive, you actually don't need to look into an archive of an archive. So it's a bit faster to start the app this way. At the same time, we wanted to make that a bit more first class. And so what we've done is we've improved the layer tools that we have. It's now called tools because it does more. Let me see, build lib status.jar. So it's like standard. So if you add jar mode tools to the command line invocation, rather than starting the app, it will offer you, you'll enter tools mode, if you will, and get the help file by default. So if I'm asking about extract, for instance, it will give me some information about the extract command. So the extract command is really your first step. That's really what you should be doing. If you're not using build packs, or if you're not like already adding some optimizations in your containers or in your deployment script in production or whatever, really the first thing is to use extract. Let's have a look to that. Destination, build, app. Without help, that probably is a good idea. So if I go to build app, I now have a structure with at the root my application, which is no longer the repackage archive, because you could see that the size is not the same, right? Then a lib directory with all my dependencies. So I could do this. And I'm now starting in, like, it's quite a boost for a small app, right? We went from 2 seconds to 1.4. Because you don't need to do all that processing, and the bootloader is skipped. So that's already a first good step. Who knows about CDS, or AppCDS, it was called before? Nobody? Except you? Okay. So AppCDS, believe it or not, it's a feature that was introduced in Java 9. So it's quite some time ago. In a nutshell, the idea of AppCDS is you create a cache of the classes. Well, that's what it was at the beginning anyway. And you can share this cache with multiple processes of the same application, and you avoid having a permgen space that's actually duplicated every time. So you try to optimize your memory this way, and the startup time, of course. In the meantime, they moved to actually a single process, and they moved much more to actually caching things, so that the application startup is optimized. And with Project Laden, they even go further. They're now like caching more things and even improving startup time. But Project Laden is still ongoing. There is not even an early access build, so it's very early. But anyway, if there is one thing you should remember from this talk is CDS. Look at it, because that's quite interesting, and the impact on you as a developer, on DevOps, if you're a DevOps engineer, is really low. So let's have a look to actually what you need to do. So CDS works by a training run. So you run the application once, and you ask the JVM to store the cache when it exits. The integration with Spring that we have, and that's where you can see this property here, is to integrate with CDS in a way that we don't start servicing requests. So we start the application up to a point where most of it is actually loaded in terms of classes. And then we do a shutdown, I wouldn't call that a hard shutdown, but we stop the JVM essentially. So that gives CDS a chance to do its thing. And then now we have a cache now that has been created for our app. So let's use it. That should be that. And with that, I'm like starting sub-seconds just by doing this. Okay. The extract command that I was showing you, I have 45 minutes left, nice. Seconds left. Go away. The extract command I was showing you is no incident, because the way we craft it specifically so that it's CDS friendly. Because if you create the cache, if something changes in the way you start the application, the cache will be busted, and you'll have to recreate the cache again. So we've worked with the platform team at Oracle just to make sure that what we do makes sure that you have a single command, and the information that we pass to the JVM will be consistent. Like the order of the jar file will be consistent. We will not pass directories. We will not use a star in directories, because all of that leads to CDS to bust the cache. So you create a cache once. As long as you have the same architecture and the same JVM, you can reuse it as long as the application does not change. And when the application changes again, you recreate the cache again. All right, with that, my time is left, but I'm around, so feel free to reach out if you have any question. Thanks very much.